Yeah, I started. Hello, this is Jordan Almeter. I am redoing my first lecture for this teaching course because I made a mistake and a technical error ate up my first video. Okay, so today we're going to learn about graphing piecewise functions. So previously, I have told you all about we have learned about graphing functions given a certain domain. So we know, for instance, we can look at our line graph and we say, okay, well, the interval is 0 is less than or equal to x is less than 2. Then we can say, okay, so from 0 to 2, 0 we fill in the circle on this end, 2 we keep it open because it's less than 2, and then in between we fill in. And okay, yeah, you can see that on the camera. Thanks. Okay. So now, from this material, and so for instance, if you have f of x is equal to x plus 1, then on our graph we should be able to have we should be able to graph our function in this way, where starting at 0 and ending at 2, we're able to graph our function, just that part of the function. And essentially what we're going to learn about today, piecewise functions and graphing them, is that you can take segments of graphs like this and put them together to build any kind of function you want. So for now we're just going to look at graphing piecewise functions. So our first function that we're going to look at, f of x is equal to x when x is less than or equal to 1, and x plus 2 when x is greater than 1. So the idea behind this notation is that you have your x, and then you say, okay, well, is my x less than or equal to 1, or is my x greater than 1? So we kind of use our x to look up which of these functions we want. And if it's in the right interval, if it's in the interval we want, we take that function and we output our x. So for instance, we remember our tables from earlier, from previously. So let's say we tried -1. Well, x equals -1. -1 is less than or equal to 1, so we just output our x. 0. Again, that's less than or equal to 1. 1. And we output x, which is a 0. We have 1. 1 is less than or equal to 1, which we remember. So then we just output x, which again is going to be 1. Now it's when we get to this point that we cross over from one interval to another that we have something interesting happen. So we try, okay, what's f of 2 going to be? So f of 2 is going to be we have 2, we look, okay, 2 is greater than 1. So we output 2 plus 2, x plus 2, so that's 4. And we see a pattern going on here, but this pattern's broken. And yeah, so we can graph this function. We note here is x equals 1. So in order to graph our function x on the domain, so here's what we do. We graph our function here on this domain. We graph this function on this domain. And so, for instance, x on x is less than or equal to 1. That would be this function. X plus 2 on x is greater than 1. We look at x is greater than 1 here. We graph x plus 2. Now, when we're looking at this, we can also imagine a dotted line cutting apart our graph. And everything on this side looking like x plus 2, and everything on this side looking like just regular x. And it's with this kind of method we can use to make our piecewise functions. So I'm going to give you another piecewise function. F of x is equal to negative x plus 1 when x is less than negative 1. 2x when negative 1 is less than or equal to x is less than or equal to 1. And 2 when 1 is less than x. So again, we have our intervals. X equals 1 and x equals negative 1. And we graph these functions on these different intervals. So negative x plus 1 from negative infinity to negative 1 with an open circle at the at x equals negative 1. Looking at that, we look at this graph. It'll be of this format. We look at a graph like 2x on this interval. So we think of graphing on that domain. And then on the interval from 1 to infinity with an open circle at that end. So something nice that happens is that when we have a open circle and a closed circle overlap like that, you don't have to draw a circle. You don't have to draw a dot at all right there, but essentially it's closed, or another way we talk about it later in calculus is that it's continuous. The idea that you can draw it without lifting your pen off the paper. So yeah, so in order to graph these piecewise functions, you split it up it's split up into functions on each individual domain, and then you just graph those functions individually on the same paper on each of their respective domains. Okay.